Let us now look at Chapter 5.5, Example 3 on page 2. The question says, the sum of the digits in a two-digit number is 13. If the digits are reversed, the number formed is 45 less than the original number. Find the original number. So firstly, we want to identify what are the two unknowns that we are supposed to find. To find the original number, we will need to find what are the two different digits that form up the number in the first place. And then we are going to assign variables to these unknown two digits. I'm going to name my two digits P and Q. You can also use X and Y, but in this question, it is given that let P be the number in the tens place and Q be the number in the ones place. So with this, we will need to form our two equations based on the information given. In the first line, it says that the sum of the digits is 13. So I'm simply going to have P, which is the first digit, plus Q, which is the second digit, to equate to 13. Remember to label your equations. So this will be my first equation, equation 1. Okay, now to find the second equation, I'm going to do an explanation by the side to help you understand better. So when we want to find the value of a two-digit number, okay, I'm going to use a random number to show you this. Okay, let's say if I have the random two-digit number 42. 42 is made up of 40 plus 2. So 4 is the first digit. To find the value of this, we need to multiply 10 because the digit 4 is in the tens place. Hence, to find the value of this, we'll have 10 times 4 plus 2, which is in the ones place. Hence, we do not need to multiply anything to it. Okay, so applying this back to this question, to find the value of the number, the two-digit number PQ, what we actually have is 10 times P, because P is in the tens place, plus Q. This will give us the value of the number. Okay, in the question it says that if the digits are reversed, so let us see what happens when the digits are reversed. Okay, so instead of PQ, now we will have QP, where Q is the first digit and P is the second digit. So to find the value of this new reversed number, we'll have 10 times Q, because Q is in the tens place, and plus P, because P is in the ones place. So let us now try to form our second equation. Okay, so our second equation will be the original number, which is 10P plus Q, minus 45, because the reversed number is smaller than the original number. So on the right hand side, this is the reversed number. Take a little time to digest this first. Alright, so now that we have two equations, we're going to try and solve this simultaneously using either the substitution or elimination method once again. Okay, in my case, I'm going to use the substitution method in this question. So from equation 1, I'm going to bring Q over to the right hand side, which gives me P equals to 13 minus Q. Next, I'm going to substitute equation 3 into equation 2. Remember, you cannot substitute it back into the equation that it was originally derived from. So since equation 3 was derived from equation 1, you cannot substitute it back into equation 1. Alright, so now substituting it into equation 2, I will replace my P with 13 minus Q. So wherever my P was, I'm going to bracket 13 minus Q into it. Okay, once I have this, I'm going to simplify it by expanding. So I will have 130 minus 10q plus q minus 45 equals to 10q plus 13 minus q. Next, after expanding, we want to simplify by collecting like terms. So 130 minus 45 gives us 85. Negative 10q plus q on the left-hand side gives us negative 9q. Now let's look at the right-hand side. 10q minus q will leave us with 9q, and 13 we'll just copy it down. So moving all the numbers to one side and the variable q's to the other side, we'll have 85 minus 13 equals to 9q plus 9q. Remember, when you move your terms over to the other side of the equation, you must change the signs. So with this, 72 is equals to 18q. Solving this, q will be equal to 72 divided by 18, which will give us 4. Once we have q, we can try and find what our p is. So I'm going to put it into equation 1. So p is equals to 13 minus q, which is 4. Hence, p is equals to 9. Okay, now that we have found that p is 9 and q is 4, check if your solution is correct by substituting the values back in. So in the first equation, you have 9 plus 4, which is equals to 13 on the right-hand side. So this is correct. And for the second equation, you will find that you will get 49 on both sides of the equation. So since it's balanced, we'll say that p equals to 9 and q equals to 4 fulfills the equation. Lastly, don't forget to interpret the solution and answer the question. The question asked us to find the original number, not to find what the individual digits are. Hence, we have to answer it and say that the original number is 94.